I see nothing. So let's try again. There we go. All right, so quarters and nickels, 20 total. This is a money problem, clearly. How do we do money problems? Remember, we have two equations. First equation, second equation. First equation has no money in it, and the second one's all about money. Remember how we separate those out? No money, all money. And the no money one, I'll go quarters plus nickels is 20. That's just nothing to do with monetary value there. That's just treating them like objects. Just however many quarters, however many nickels, 20 total objects, total coins, right? Nothing about their value. No money, no money, no money, right? Second equation, you bring in the money. Quarters are worth 25 cents, as you know. Nickels are worth 5 cents, as you know. And the total money is $240. It's not, by the way, 240 times 20. Don't make that mistake. That's what you do for the mixture problems. Remember, you multiply, multiply, multiply for the second equation on the mixture, but we don't do that for the money ones, right? 240 is the total money, right? They're not saying the person has $2.40 20 times, are they? They're just saying all the quarters and nickels make 240, period. So watch out, easy mistake to make. Okay, we good there? So the second one is money, money, money. Now we just need to solve. How do we solve? You can do lots of ways. I'm going to make the fronts opposites. That's what I was doing all day yesterday, right? Let's make the fronts opposites. So I'll multiply this by minus 0.25, minus 0.25, and minus 0.25. And so then we get minus 0.25q minus 0.25 in. Is that minus 5 over there? The bottom one, let's bring the bottom one down, no changes. And then add the two equations, these cancel. This is minus 0.20 in, this is minus 2.60. Good to there, right? We canceled out the q's. That's what you got to get one of the letters to eliminate, right? By making them opposites. Okay, so then finish solving for n. Just divide by minus 0.20. Like that, divide both sides by minus 0.20. Cancels out, n is 13, huh? 13 nickels, that answer wasn't there, it's none of the above. Questions on that one? You good? You okay? Did you make it through all those last night? You keeping up with this class? We did money, mixture, travel, all those perimeter word problems. That's a load of work. That's a lot of problems. All right, if you're having any trouble, Roberto, he was here in my first class this morning. He's available. What are his hours today? Thursday. Oh, he's done with his hours today. But he will be around on Monday before class. No. Oh, he's during our class on Monday, isn't he? Yeah, so he's not really available till Tuesday for you guys. Yeah, so yeah, he's not around right now. There's other tutors over there, though. So get the help you need. Keep up with this material. In a week, you'll be taking the final. And you will have completed 5 units, hopefully. Yeah. Let's jump back to this one real quick. 7.5, number 5. Set up the dirt equation. It's a travel problem. Read it real quick. Countin rides a bus part of the way to work every day, walks the rest of the way. Bus averages 40 miles an hour. Countin walks at a speed of 3 miles an hour. Distance from home to work is 21 miles. Total time is 3 hours. Find how far the accountant walks and rides. Okay. So basically, this accountant gets to work, and he does it by riding the bus part of the way, walking part of the way. So he does both those things. So the two things we have up here are bus and walk. Bus and walk. So accountant rides the bus and then he walks. So those are the two kinds of parts of the trip. So the bus averages 40 miles an hour. That's the rate for the bus. 40 miles an hour. And he walks at 3 miles an hour. That's the rate for walking. So the distance from home to work is 21 miles. That's the, now, before I throw that in a box, careful, because you might think, oh, just, that's just the distance, 21. Well, it's not the distance. I can't put it there because it's not the distance. That would be the bus distance, right? And they're not saying the bus distance. They're saying the total, like he goes all the way to work. That total distance is 21 miles. But we know he rides probably most of it. And then he walks part of it. So the whole 21 miles, part of that's riding the bus, part of that's walking. I can't put 21 in either one of these boxes because, if I put it here, that would be how far he does the bus. If I put it here, it'd be how far he walks. The 21's the whole thing. It's not the walk or the ride alone. Where you can put 21? You can put it right there. It's going to be the total of those two distances, isn't it? Does that make sense? I know we've never done that before. That's why this one's an extra tricky one. Okay, let's keep going. Time, 3 hours. 3 hours is the total time. Again, I can't put that here. He goes there. Yeah, because 3 hours is the total time for busing and walking. It's not either one alone, right? Okay, now, well, remember how we always have to get the right 4 boxes? So now, can I go X and X? Because I've done that a lot in the past. Not here. That's why this one's, again, extra tricky. It's a curveball. So why can't you go X and X out there? Well, if you call them both X, like we did in so many other problems, you're saying they're equal. Well, like if X turns out to be 7 later or whatever it is, then they would both be 7. You're forcing them to be equal when you call them the same letter. And normally, I know that's the case. Normally there'll be something goes blah, 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 same time, right? So then I know they're the same, call them both X. No such phrase in this problem. And in fact, no good reason at all to believe that these two guys are the same. He doesn't ride the bus the same amount of time that he walks. So you got to call them different letters, X and Y. See the trick? Okay, so this one's got a little more wrinkles to it. So now we've got the 4 boxes on the right. So you know how to get the left boxes, multiply, right? The D box equals the R box times the T box. So this D box will be 40X, and this D box will be 3Y. Good. There's one equation. Now, 2 letters, we need 2 equations. Here's your first equation. The 40X and the 3Y have to add up to 21 for total distance. Here's your other equation. The X and the Y have to add up to 3 for total time. There's your 2 equations with 2 letters. So this is a more advanced problem. So 40X, 3Y, 21, X plus Y, 3. There's our 2 equations, 2 letters. And so now, can I leave it at that in the interest of time? Just go on and solve. You'd maybe multiply the bottom one, say by negative 40, boom, 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 right? Just multiply, I normally don't show it that way, do I? Now multiply all 3 by negative 40. I'll show it like I normally do. Negative 40, negative 40, negative 40. Like that. So then we get 40X plus 3Y. So the bottom one is minus 40X minus 40Y minus 120. Add them up. X's cancel. Minus 37Y is minus something. Was it 99? Yeah. And then divide by minus 37, and you've got it. We got Y, and then you get X and all that. That's how you do it. Is that good? Good enough? Leave it at that. For the bus problem, the accountants. That's tricky. 2 letters, X and Y, in a distance rate time equation. So, all right. I'm not going to put one that hard on the test. All right, so we're in chapter 8. So the game plan for today, 8.1, 8.2, 8.3, complete all those. They'll be due on Monday, and then we'll do some of 8.4, a little bit of 8.4. I won't finish it. It's not due on Monday. I'm going to update Math Excel because Math Excel currently says it is due on Monday. So I'll fix that. So that's the plan. Chapter 8. You're going to like it. I mean, I'm not just joking. I think you will. Square root of 49. What's square root of 49? 7. See, we're off to a great start. Everybody already knows the answer. Yeah. This is the square root chapter. This whole chapter is about, they call it radicals, that's the official math term, but roots, square roots. So how do you do square roots? You guys know, square root of 49 is 7. All right, there's the next one. Negative square root of 4. Well, don't let that negative sign bug you. He's just a spectator. He's just sitting in the front. He's not doing anything. What's square root of 4? 2. We're done. Negative 2. Easy enough, right? Okay, so negative square root of 225. Anybody know that one? Nice memory, yeah. 15, you use calculator though. Just root 225 is 15. The negative sign sitting in the front. The negative sign's not doing anything, right? Just sitting there, it's just a spectator. Hey, what if you were to teach this to a 10-year-old? I could show it to my 10-year-old, my Abigail, maybe when I get home. What, she'll be very excited. No, she doesn't. She won't sit still for anything like that. She's a goer. Anyway, so square root. What is it? Like, what if you were to, teach a child who hadn't seen this before, like square root of 9? The answer's 3. I mean, you know it, but how would you explain it? Like, why is the answer 3? What if the kid said why? What if the kid really cared and wanted to know? I'm not sure I know a 10-year-old that does, but what if? Just imagine with me. What if the 10-year-old wanted to know? If I promised Abby a candy bar, if she figured it out and then could do one, I would test her afterwards. That's how I would know if she really knows. I'd say, all right, you got it. What's the square root of 25? And see if she knows. So, how would you explain it? How would you say it? I think this will help us think, because they're about to do something, throw a curveball at us, and we'll be able to handle that if we're real clear what a square root really does. Like, why is the square root of 9 3? What would you say? Exactly. Well said. Exactly. Right. What times itself twice, or what thing twice, is the 9? Huh? That's it. Huh? That's totally the square root question, right? What twice is this thing, right? What times itself twice is 9? Well, 3. That's it, right? What times itself is 9? 3 is. So what times itself is 25? 5. Absolutely. Okay. Now notice they're putting the negative in the root. A minute ago we had them out front, and if it's out front, who cares? It's not important. But if it's in the root, like this one, that's a little different. Because now you're actually asking the question, which we just said the square root question is, what thing times itself? What number times itself? What number twice is negative 9? Nothing. Do you see that? Can't be. Because you can't do negative 3 times negative 3. That would be positive 9. That wouldn't be negative 9. And you might say, well, yeah, you need one negative, one positive. Well, then that's not the same number times itself. That's times its opposite. That's not allowed. Right? We agreed that square roots ask what number times its very self is this thing. So you can't switch signs. You can't do that. That's times the opposite. So you can't do it. You realize it's impossible? That's why the square root of negative 9 is not. They're saying, is it a real number? No. Do it in your calculator, say error. You can't do it. So, and it's not just for negative 9. It's the square root of negative anything, huh? That's anything. Anything. There we go. Anything is not real. You can't do it, huh? So the negative outside is no big deal. That's just negative 3. Right? If the negative's outside, he's just a spectator at the event. He's just watching. He doesn't care what goes on with the square root. It's like me when I go watch my kids play baseball or soccer. I'm just watching. I'm not on the field, although sometimes I want to be on the field, but not the soccer field. I don't know how to play soccer, but baseball was my sport. So anyway, the negative is just watching. It's just watching. It can't be involved if it's outside. But if it's in the game, if it's in the root, then, you got to think about it, and you can't do that. Negative in a root, no. There's no number times itself that ever comes out negative, right? Because negative times negative goes back to positive. It's impossible. All right, so they'll give you some. Okay, so negative square root of negative 25. So the negative in the front is no problem. We're fine with him. He's just a spectator. He's not in the game. He's not in the root. But this one's a problem, huh? Not real. So just doubly emphasizing, you can't have a negative in the root. The one outside's okay, but the one inside is not. It wrecks it, not real. And you can't cancel them. You can't say, well, 2 negatives cancel. No, they're in different worlds. One's inside the root, one's out. They can't do that. It's just not real. You can check it on your calculator. It'll tell you error. All right, so square root of 4x squared. So how do you square root to 4? going to be 2. What times itself is 4? 2. And how do you square root the x squared? Just cancels it out, x. Done. No more root. Root's gone. We did the rooting. Good? All right. Okay, so square root of 31d squared. So the square root of 31d quantity squared, what's going to happen with this one?
It's going to be 31d.
Yeah, the root will just cancel out the square, huh?
Just cancel out.
That's just 31d. You don't need the parentheses anymore. They're not really important anymore. Yeah, so is everybody good with that? So again, powers and roots, the 2 power and the root just cancel, eliminate each other, just like that. Okay. Yeah, why do we, well, you can keep them. You don't have to cancel them. So if you wanted to keep them, that's okay too. But why you might want to drop them off is because there's no point in them now, because there's nothing to separate them from now. Or no need to indicate them as a group. Yeah, that's what that's better said. Well, what parentheses really do, I know we think of parentheses as like multiply, and they certainly often do mean that. But mainly what they mean is this group hangs together. That's what they really mean. So what if I said, what if I was talking about us and I was saying, all right, I'm gonna do the front row, okay? The front row is gonna do a certain thing. I might group them but if I was talking about the whole class, we already are a group, right? There's no need for me to make some special indication. If I put on the board some assignment that I wanted people to do, and I just put it on the board and it was for everybody, I wouldn't need to write a note saying, by the way, this is for everybody. It's understood, right? Whereas if I wanted the front row to do a certain thing and then the other row then I would write just for the front row. That's kind of like what parentheses do. They group off a certain group and say just this group does whatever. Well, when there's the 2 power here, it's important to have the parentheses. Why they're there is because if that's a big 1. I was kind of doing a 1 and a parenthesis all at once there. If you wrote it like that without parentheses, only the d is being squared, not the 31. Does that make sense? So if you want the 31 and the d both squared, you got to put parentheses. So that's why they're important in the beginning, because you're saying, hey, this whole group, not just the 31, or not just the d, I mean, this whole group is squared. But then after that thing's gone, all you got left is 31d. So there's no gain in putting parentheses. You're just saying the whole 31d. Well, yeah, that's what this already says, the whole 31d. There's nothing to do with the group. Does that make sense? They're only crucial if you're doing something with a whole group. That's when they matter. At this point, we're just saying the final answer is 31d. We're not doing anything with the group. That's why we can drop them or you can leave them. Okay, so we've got x plus 10 squared with a root over it. So what happens there with that root over x plus 10 squared? What does the root do? Same thing, huh? The root cancels the square. Again, right now the parentheses matter because they're saying that whole group is squared, not just the 10, not just the x, the whole thing. But once the action, how about this way? Once the action is on the group isn't there anymore, then there's no need to specify the group. Right? You just say x plus 10. I mean, you can put parentheses around it if you want to, but it's not going to change anything. Wouldn't matter. All right. Okay, let's try square root of a squared minus 16a plus 64. Try that one. What do you think you need to do with that one? FOIL factor, yeah, right, exactly. Yeah, so go ahead and factor that thing out. Then you'll get identical twins is what you'll get. So FOIL factor that out to parentheses. So a times a is a squared. What times what, 64? 8 times 8 is 64. How do you get minus 16? How do they add to be minus 16? Both minus, negative 8, make negative 16 in the middle. Two negatives multiply to be positive 64. So notice that's identical twins. So we say squared. And then what does a root and a square do? They cancel. So it's just a minus 8. No need for the grouping symbols anymore. There's no action being taken on the group. So there we go. Is that good? Easy enough?